Okay, so welcome to video 2 of section 8.4. So let's consider the polar plane, which is nearly the same as the rectangular coordinate plane. So we have our x and y coordinate axes as usual. Maybe I'll make the y-axis a bit longer. Okay, so x and y coordinate axes. And let's say I have a point in the plane. So this point is going to be given by two variables, of course, r and theta, right? So the radius r is the distance, right? This is r, whereas the angle theta is that which is made with the positive x-axis. Okay, but there's some nomenclature here. So this is still an element of the plane, but now it's a polar plane. So we have a bit of different names. So the point, the origin, is now called the pole. And the positive x-axis is now called the polar axis. So let me put in parentheses x-axis. And the pole I'll put in parentheses origin. So this is just more nomenclature for those things we already know. So we can name this a polar coordinate system. So the polar coordinate system. Okay, so let's note, how do I plot a polar coordinate? So note, so given a polar coordinate, let me write coordinate a bit better. Coordinate of the form r comma theta. We extend r units along the polar axis from the pole. Then sweep through an angle theta. Okay, so let's see what I mean by this. So for example, let's plot the following on the same set of coordinate axes. So plot the following polar coordinates. Coordinates on the same set of coordinate axes. Okay, so number 1, let's have point A at 3 comma 5 pi over 6. Number 2, we'll have point B at 2 comma 5 pi over 4. Number 3, we'll have point C at 1 comma pi over 3. Number 4, let's put point D at a radius of 4 and an angle of 3 pi over 2. And then E, I'm going to kick it up a notch. Let's have my radius be a negative 3 and my angle pi over 6. So that's going to come into play with how I plot. So x and y coordinate axes. And my largest radius is 4. Let's see. So x and y. What I'm going to do is I'm going to go out. Oh, do you know what? I should not do this. I should move down because I want to be on the axis for this. Okay, so I'm going to make this a bit longer. I'll see what I'm doing in y. Okay, so I'm going to have my first circle at a radius of 1. This is just for guiding. My second circle at a radius of 2. So this is the polar grid, much like we have our rectangular grid for the rectangular coordinate system. Polar grid is a bunch of concentric circles that usually, they're not. Okay, so I'm making circles at each radius. And my largest radius is actually 4, so maybe once I get to 4 I can stop. Okay, so this is what a polar graph looks like. We also have angles of the 30-degree reference angles. Put it like right about there. Something like that. The 45-degree reference angles, which are the easiest guys to draw at least. And then the 60-degree reference angles, which are something like so. Okay, so assume that these are correct angles. I don't think they are, but it doesn't matter. For illustrative purposes, they work. So, part A. From the pole, I'm going to go out to a radius of 1, 2, 3 to the right, and I'm going to sweep to an angle of 5 pi over 6. So I went from the pole 1, 2, 3 to the right, then I swept through an angle of 5 to 5 pi over 6, so this is point A. And here's 5 pi over 6, and this is a radius on the circle of radius 3. So now let's do the same for point B. So I start at the pole, and I go to the right 2 units, and then I sweep through an angle of 5 pi over 4. Well, 5 pi over 4 is in quadrant 3, so this is 5 pi over 4. And I'm on the circle of radius 2. Now let's look at C. So from the pole, I go out a radius of 1, and I sweep to an angle of pi over 3. So C is at pi over 3 on a circle of radius 1. Let's look at D. So from the pole, I go to the right 1, 2, 3, 4, and I sweep to an angle of 3 pi over 2. So this is 3 pi over 2. And I'm at a radius of 4 on the circle of radius 4. Now here comes the pièce de résistance, as it were, E. From the pole, I'm going out a negative 3. So 1, 2, 3 to the left, because my radius is negative. And then I'm only sweeping out pi over 6 from there. Notice that because my radius was negative, this is just a 5 pi over 6 sweep. However, I end up at 7 pi over 6. So note that this angle here is just pi over 6 that I swept through. It was because my radius was negative. So we need to note that. What happens when your radius is negative? You're 180 degrees from the angle indicated. So note. So do you agree that 7 pi over 6 is 180 degrees from pi over 6, right? So if your radius is negative, so if radius is negative in r comma theta, then plot at r, or at absolute value of r, comma theta plus 180 or pi. Okay, so that's what happens when we have negative radii. Okay, so let's recall, pardon me, and I did this in the last video, so I'm sure you remember it, that our radius is always the square root of the sum of the squares of the components x and y. And our angle theta is always inverse tangent of the quotient y over x with respect to the quadrant. We also know that x is r times cosine of theta, whereas y is r times sine of theta. So we have all of these identities. So, for example, let's use all of this to express the following equations in polar form. So express the following equations in polar form. Okay, so number one, let's say we have x squared plus y squared is equal to 25. Okay, well, what do I know? I know that r squared is x squared plus y squared. Okay, so therefore, if I have x squared plus y squared is 25, I can simply rewrite the left-hand side of the equation as r squared is 25, and there you are. That's polar form. However, r equals to 5 is equivalent. So, we'll come back to that. A radius is a distance, and I would say it can't be negative in an equation, but we just had a point that with a negative radius. But what that really did was change the angle. The radius was still a positive because it's a distance, right? You can't take a square root and have it be negative. So number 2. So let's say I have 2 times x times y is the square root of 3. Okay, so first off, I know that x is r cosine theta, and I know that y is r sine theta. So what I'm going to do is I'm going to use that to rewrite 2 times x times y is equal to the square root of 3. So this will now be 2 times r cosine theta times r sine theta is equal to the square root of 3, otherwise known as r squared times 2 sine theta cosine theta is equal to the square root of 3. And the reason I took 2 sine theta cosine theta is because that's the double angle identity for sine. So this is really sine of 2 theta is equal to the square root of 3. So there we are. That is the polar form for that. Okay, so number 3. Let's have x squared minus y squared is equal to quantity. Let's do x plus y squared and see what we get. Okay, so we know that x is r cosine theta, and we know that y is r sine theta. So let's go ahead and rewrite this whole equation. So we have x squared minus y squared is quantity x plus y squared. So x squared, x, y squared, y. Okay, so this gives us r squared cosine squared theta minus r squared sine squared theta is equal to quantity r cosine theta plus a quantity r sine of theta all squared Okay, so on the left-hand side, I'm going to factor out an r squared because what remains is cosine squared theta. Guess I'll try and keep the cosine squared theta minus sine squared theta, which is actually the double angle formula for cosine. Now I'm going to expand the right-hand side, which will be r squared cosine squared theta. Might not have enough room. Let's see. Plus 2r squared sine theta cosine theta. Nope, I'm not going to have enough room. Okay, so maybe I will move this. Oops. Move this down here. Okay, so plus the final term when I expand will be r squared sine squared theta. Okay, so on the left-hand side, what do I have? I have r squared times what amounts to cosine of 2 theta, and that's equal to, I can factor in r squared from everything on the right-hand side. Let's see. What do I know about cosine squared? Well, actually, cosine squared plus sine squared leaves me with 1 plus, well, when I factor out the r squared, I get 2 sine theta cosine theta, which is sine of 2 theta. So reducing the r squareds, I end up with cosine of 2 theta is equal to 1. What color did I use? Was it that one? No, I didn't think so. It was this one. So 1 plus sine of 2 theta. And there we are. Now it's in polar form. Okay, that's number 3. Okay, so let's go backwards now. So for example, let's express the following in rectangular form. So express the following in rectangular form. Okay, so number 1, let's say we have that r is equal to 3 sine theta. Okay, so rewriting r is equal to 3 sine theta. I know that y is r sine theta. So let's try and multiply through this equation by r, so that on the left-hand side I'll have r squared, and I'll have 3 times r sine theta on the right. So now I can replace r sine theta with y. So I get that r squared, well, what is r squared? I know r squared is x squared plus y squared, so I could write this as x squared plus y squared is equal to 3 times y. And there we are. Should I be putting more room in between these? Hopefully you guys can see these. Let me move this down, maybe 1 line. Okay, so number 2. Let's say we have that r is equal to 7 times cosecant of theta. Okay, so we have radius is 7 times cosecant of theta. But what is cosecant? Cosecant is really 1 over sine. S's and C's go together. So what I can do is I can cross multiply by sine of theta. So I'll have r sine theta on the left. R times sine of theta is equal to just 7 on the right. But I know r sine of theta is y. So I can replace this with y is equal to 7. And there we are. That was simple. Okay, so number 3. So let's say we have r sine of theta is equal to r times the square root of cosine of 2 theta. Okay, so let me rewrite this. R times sine of theta is equal to r times the square root of cosine of 2 theta. Okay, so what I'm going to do, before I change the left-hand side, which I know is y, I'm going to push the r underneath the radical. So I'm going to push this r inside the radical. In order to do that, I need to square it. So this now becomes r squared. And I know that cosine of 2 theta can be rewritten as cosine squared theta minus sine squared theta. Actually, I should skip a line. This is getting confusing. Let me skip a line here. And then I can distribute the r squared to each of these squares. So I have r sine of theta is equal to the square root of r squared cosine squared theta minus r squared sine squared theta. And now I'm ready to replace. Okay, so on the left, I know r sine of theta is y is equal to the square root of, on the right, what color shall I use? Pink. R cosine theta is x, so this is x squared minus, and r sine of theta is y, so this is y squared. And there we are. Now we have an equation in rectangular form. Okay, so hopefully this is making sense. We can just leave it like that. We don't need to square both sides. Okay, so I think I'm going to stop here for this video.